eg2, we start by drawing our diagram. So we have a uniform ladder. So remember that means that the mass acts at the centre. And we have then a weight acting down of 30G. Rests against a smooth wall, smooth, so that means that there is no friction force, but we do need to have a reaction force. We have on rough ground, so there will be a reaction and friction, and I'm going to label this force X. I'm now going to consider my forces. We're in equilibrium, so the left forces have to equal the right forces. So friction has to be X. Up forces have to equal down forces, so R is 30G. And I also know that friction equals mu R, so that will be 0.25 times 30G, which is 73.5. To work out X, we're going to have to take moments, and I'm going to take moments about the base of the ladder, so I'm going to label it A. Take moments, I'm going to have to add the angle to my diagram and the ladders at 60 degrees. So if we start at A, the first force that we meet is 30G, and it is halfway up the ladder, so I'm going to call that D over 2. The moment will be this distance here multiplied by the force, and that distance is the D over 2 cos of 60, and it's cos because it's beside the angle. So our moment is 30G times the distance of the ladder for 2 cos of 60. Then we have to decide what the motion of the moment will be, and this one is going in a clockwise direction. I'm now going to repeat this with the force X. So if I start at the base of the ladder and I go up to X, I have travelled D, distance up the ladder, and this is what I'm looking for. If we have 60 using alternate angles, this must be 60, so this distance here is D sine 60 because it's opposite the angle. So the moment is X times D sine 60, and that's going to be in an anti-clockwise direction. I know that the moments are in equilibrium, so XD sine 60 has to equal 30G D over 2 cos 60. My D's cancel, and I'm left with an equation with only one unknown, which is X. And if I do 30 times 9.8 divided by 2 cos 60, and then divide by the sine 60, I get 84.87, which when we round to 3SF is 84.9 newtons.